Hello, today I'm going to go through how to work out the rest of the specific heat problems worksheet. Keep in mind the formula for specific heat says that Q equals M times C with the little p that's not really important times delta T, which stands for change in temperature. So I already did problems 1 and 7, so I'm going to do the rest of them with you now. So in problem number 2, we're trying to calculate the number of joules, which is Q, released when 75 grams, that's our mass, of water, the specific heat of water, when it's between 127.5, that's going to be liquid water. Its specific heat is 4.18 joules per gram degree Celsius, and it has a change in temperature of 72.5 degrees, because that's the difference between those two numbers. So we just multiply those numbers together and we get 22,728.75 joules. In problem number 3, it wants us to calculate the amount of heat that's needed to warm 225 grams of water. And since we're working in the water, it's 4.18 is its specific heat. And we're going from 88 to 100 degrees Celsius, so our change in temperature is 12 degrees Celsius. So we just multiply those out, and we get 11,286 joules. And problem number 4, it wants to know how much heat would be needed to warm 250 grams of gold. And so if you check on the front of your reference tables, you'll find the specific heat of gold is 0.129 joules per gram degree Celsius. We're going from 25 to 100, so that's a change of 75 degrees Celsius. So we multiply that out, and we get 2,418.75 joules. Which is interesting because in problem number 4, we're heating up a lot more gold by an even greater temperature amount than we did the water in problem 2. And it only took a small fraction of the amount of heat, 2,000 joules versus 22,000 joules. And that's because the specific heat of gold is so much less. In problem number 5, working with 454 grams of zinc, which has a specific heat of 0.388 joules per gram degree Celsius. And if we're going from 96 down to 28 degrees, the difference in that is 68 degrees. So we multiply that out, and we get 11,978 joules. In problem number 6, it's wanting to know what a final temperature is. So they're giving us joules, 3.31 times 10 to the third joules. And then we have 18.5 grams of water. So its specific heat is 4.18. And we don't know the temperature change. We know what temperature we're starting with. So we're solving for delta T. So to do that, we're going to take these two numbers and divide them into the 3.31 times 10 to the third. When we do that, our temperature change is 42.8 degrees Celsius. And if we started at 22 and we added heat, so we're going to add 22 degrees to that, we're going to end up with 64.8 degrees Celsius. In the last problem, problem number 8, is wanting us to calculate the specific heat of platinum. So we're solving for C. Well, our joules are 1,092 joules. That equals 125 grams times the specific heat times the change in temperature of 65.2 degrees. So when we solve for specific heat, we get the specific heat is 0.134 joules per gram degree Celsius.